Welcome to Maths with EJD. Still talking about series of ordinary differential equations or series of differential equations. And in the last video, we had considered the method of undetermined coefficients for non-homogeneous linear systems. We continue with that same thought as we look at first oscillations and resonance, and we still use method of undetermined coefficients before we go for variation of parameters method in the next video. Okay, so since we talked about the fact that um, non-homogeneous systems have a forcing term, and that term is like exerting an external energy on the system, and that's what leads us to forced oscillations and resonance now. So forced oscillation talks about some kind of forcing coming from outside to, you know, have an impact on the system. So a forced, or better still, a forced oscillation a forced oscillation occurs in a system governed by a non-homogeneous linear differential equation where an external periodic force drives the system. The general form of such a system is x prime equals ax plus f of t. Of course, it's still the same pattern with all we've been considering, still the standard non-homogeneous linear system kind of thing. Okay, so here where x of t is the state vector, then A is a constant coefficient matrix. And then we have the forcing part, f of t is the external forcing function. And it is typically periodic, e.g., it could be something like f of t equals f naught e raised by I omega t, which is clearly periodic. Now let's talk about the solution structure for this. It's just like the normal homogeneous thing we've been talking about, the normal non-homogeneous things we've been talking about rather. So the general solution consists of one, the homogeneous solution, which we can call xh of t. So we already know how this is found by standard. So this is found by solving x prime equals ax. That's the non-homogeneous part. So which gives oscillatory behavior. It gives oscillatory behavior. Since we are talking about first oscillation, it gives oscillatory behavior if the eigenvalues, if the eigenvalues of A have imaginary components. Okay, then we have the second one. We have the particular solution, which we call xp of t. So this can now be found using the method of undetermined coefficients. So we can use undetermined coefficients like what we already saw. Undetermined coefficients. We can even use variation of parameters. We can use variation of parameters. Of course, that will be considered in the next video. So here we'll be using method of undetermined coefficients. So we can then say that for a sinusoidal, forcing function, that's a function that follows a sine wave. So we assume a solution of the form xp equals c e raised by I omega t. Of course, we know that's the same thing as maybe that's simply the same thing as c into say cos omega t plus sine omega t, something like this. Okay. So we have this, right? And we assume that solution form and solve for C. That's how that goes. So let's look at another side to this. Okay, let's look at an example I made. So example, considering forced oscillatory system. Okay, so consider the system. There you have x prime, y prime equals 0, 1 minus omega naught squared 0 xy plus the forcing term 0 f naught cos omega t f naught cos omega t, okay, where omega naught is the natural frequency of the system. Then f naught cos omega t is the external forcing function. External forcing function. Okay, so in all this now, this system, okay, let me just maintain what I was using. This system represents a forced harmonic oscillator which is common in mechanical and electrical oscillations. Mechanical and electrical oscillations. So how do we deal with that problem? The first thing we want to do is solve step 1, that is solve the homogeneous system. That's the procedure we are very used to now. So the homogeneous system is x prime, y prime equals 0, 1 minus omega naught squared 0 x, y. So that's the homogeneous system, which can be rewritten, so we can rewrite it as an order 2 thing, which can be rewritten as the second order equation. So we can write that the second order equation x prime prime plus omega naught squared x equals 0. Okay, I mean, if I were to rewrite this right normally on its own, so it would be like x prime. Okay, I guess I need to use another kind of color. So if we're to write this right, it would be like x prime equals x times 0. So x prime equals y. And then we now have y prime equals minus omega naught squared x, because y will also be 0. So this is, so we can put everything back together and we have a second order differential equation, because we know that from here now, x prime prime is equal to y prime. Okay? X prime prime is equal to y prime. And if that is the case, that simply implies that uh, that x prime prime is equal to y prime now is minus omega naught squared x. So that means we have x prime prime plus omega naught squared x equals 0. So you see how that transformation takes place. That is why we can confidently have this other form of representation for it. And this is exactly what happens. We can also break the second order into a system of differential equations, a system of first order like this. So, but I mean, having it this way makes things a bit easier, because we can now get the characteristic equation. So the characteristic equation is lambda squared plus omega naught squared equals 0. That means that lambda squared is equal to minus omega naught squared. So lambda alone is equal to plus or minus I omega naught when you take the square root of both sides. Okay. So we have this because it's complex. So we can have the homogeneous equation. So thus the homogeneous solution, the homogeneous solution is xh of t equals, because of the way of the answer is, so that will be equal to C1 cos omega naught t plus C2 sine omega naught t. So this is the homogeneous solution. Okay, I guess I just want to maintain this. So for the velocity, or the velocity y, which is equal to x prime, so we differentiate. So that means we have x prime. Okay, yeah. So we have x prime, xh prime of t. Oh, okay, yeah, I get it. So it means that y, which is x prime, right, means we are differentiating this. So when you differentiate cos, you get minus sine. So this is minus c1 sine omega naught t. When you differentiate sine, you get cos. That's plus c2 cos omega naught t. So that's y now, because y is equal to x prime. Okay. In that case now, in vector form, we can have it now. So we can say thus the homogeneous solution in vector form is xh of t equals c1 multiplied by cos omega naught t, then minus omega naught. What did I do here? Oh, yeah. So this should, omega naught should come out here, right? And another omega naught comes out here. Yes. So that's what we should really have. Okay. So we have minus omega naught sine omega naught t for this first part. And here we have sine omega naught t, and then we have omega naught cos omega naught t. So that is the solution in vector form. I guess I'm also missing out something here. We should have plus c here, plus c2. Yeah, we have c2 right there. Okay, so that's the first part of the solution. Talking about the second part now, where we have step two. So step two, we now solve for the particular solution. Okay, so the forcing function, since the forcing function is f of t, which is 0 f naught cos omega t. Is it omega t? I think it's omega t, not omega naught t. I think it's omega t. Yes, omega t, not omega naught. Okay. I mean, that's understandable, right? So omega naught t. So since we have that, we assume a particular solution. We assume a particular solution of the form, because we have a cosine, right? If you can, so we are going to have cosine and sine, because when you differentiate cosine, you get sine. So it means our f of t for the particular, our xp of t, that is based on this f of t, xp of t will now have to be, so undetermined coefficient a cos omega t. When you differentiate omega t, you get sine omega t. So b undetermined sine omega t for the first one. For the second part, then you can continue c cos omega t. That's for your y prime. C cos omega t plus d sine omega t. So we have that. So then we need to substitute. So substituting xp of t into the system. Okay, if we substitute into the system, right, it means we are going to have okay, I mean the system itself, right, originally is xp prime yp prime equals 0, 1 minus omega naught squared 0, then xp yp plus 0 f naught cos omega t. Okay, like this. So we need to compute the derivatives. So computing derivatives, we have up to just one derivative, interestingly. So computing derivatives now, we get xp prime of t to be equal to, for the xp we have up there, right? So it's equal to, so this is everything together, right? So xp prime of t will just be this first one, a cos omega t plus b sine omega t. That'll be minus a omega, all right? Minus a omega sine omega t. So minus a omega sine omega t, okay, plus b omega cos omega t. That's when we differentiate this first line here. When we differentiate the second line, we have something similar, except that now we have c omega, right? Minus c omega. So yp prime of t will just be minus c omega sine omega t plus d omega cos omega t. So we have those two. So if we expand the matrix, um, so expanding the matrix multiplication, especially this system we have rewritten, Where is it now? Yeah. If we expand this system based on what we now have, XP has a value, YP has a value. And by that, what we simply mean is that this is now XP and this is YP, right? So if we expand that, it means that we have, so XP prime, YP prime, like this equals 0, 1 minus omega naught squared 0 into A cos omega t plus B sine omega t. Then here we have C cos omega t plus D sine omega t. All of this plus 0. Then F naught cos omega t. Okay, so if we tidy that up, this gives xp prime of t, then yp prime of t, and that is equal to, so up there now, this multiplied by 0. So if you put 0, 1 over this, so 0 cancels the first one. So we just have C cos omega t plus D sine omega t. So C cos omega t plus D sine omega t. Then for the second one, we have this. So put minus omega naught squared over this. So 0 cancels the second one. So we have minus omega naught squared multiplied by the first line, right? So we have minus omega naught squared A cos omega t minus omega naught squared B sine omega t. Okay, all of this plus 0 F naught cos omega t, 0 here. Okay, so that's what that gives. So we now need to match coefficients. So matching coefficients for cos omega t and sine omega t, we obtain, so we have to compare, right? So, C cos omega t plus this sine omega t, if we compare that with xp prime, the xp prime here, right? So for sine over omega t, we have minus A omega. For cos, we have B omega. Okay. So if we compare this now, so here we have for cos we have C. For sine, we have D. So basically, if we do that, right, we have okay, let's do it 10 by 10. Let's start with cos, right? So for cos omega t, for cos omega t, on the left hand side, on the right hand side, we have C. Okay, so this C now will be equal to um what is that? Yeah, C will be equal to minus A omega. So C is equal to minus omega A, or even A omega if you like. So we have C to be this. So we can keep this. Then we also have sine omega t. So for sine omega t, on this side, we have D. We have D going together. So this D goes together. The D here goes together with B omega. Is that what it should be? D, so for XP, blah blah. Okay. Okay, I think this is what we should be comparing. So for XP of T, C goes with that, then D goes with D, the coefficient of D with sine. So the coefficient of sine omega T here is D. And then we compare it with sine again. I mean, for cos, that should be, Um, let me see. If you differentiate some, we get cos, right? So that should be omega b. I guess I need to do something more proper, right? So this is, of course, this is just zero here. And when we come down to this place, yeah. So I think it makes sense. XP. XP itself is b sine omega t. If we differentiate, we just get plus now. So there's no negative sign. So d is equal to omega b in short. So d is equal to b omega, if you like. So that's what we have right there. So another part is, and this is for xp prime of t now. So for yp prime of t, so for yp prime of t, then we go again cos. So for cos omega t on the left, for cos omega t from our expansion. So for cos omega t, we have cos here and cos here. So that's minus omega naught squared a plus f naught on the right hand side. On the left hand side, for cos omega t, we have d omega. Okay, we have d omega. For cos omega t, we have d omega. So this is d omega equals d omega is equal to, for this now we have minus omega naught squared a plus f naught minus omega naught squared a plus f naught. These are the coefficients of cosine, right? Coefficients of cosine. Okay. And then we have this like this now. Then for sine omega t, comparing the two, for sine omega t. So on this sine omega t at the top here, the coefficient is minus c omega. All right. So we have minus c omega equals, then for sine here, we have minus omega naught squared b. Minus omega naught squared b. Okay, we have this now. All right, so we need to find our A, B, C. We need to find all of these things. We need to solve for, we are looking for A, B, C, and D. Okay, so how do we take care of this? First of all, we have, how do we do this? C, 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 C. So we can substitute, yeah, we can substitute, right? So substitutes, because C and D are this value, so we can just substitute them here, right? So let's call this equation 1, and then let's call this equation 2. So we now say substitute. So substitute substitute 1 into 2. Let me just put it that way. 1 into 2. So uh so it means that whatever D here is B omega. So we just bring B omega for D. Okay. Okay, this is 1A. This is 1B. This is 2A. This is 2B if you like. So substitute 1 into 2. So that means C is minus A omega. Put that into 2A. Put C, which is minus A omega, into 2B. So what that means is that we have minus, instead of C now, we have minus A omega there, then together with the omega that was there before, and that is equal to minus omega naught squared B. So we keep that. We can tidy things up. So we have A omega squared equals omega naught squared B. Okay, that's omega naught squared B. So that's like, yeah, we can, let's leave it this way first and see what happens. Then for the next one, uh, so that's for C. So for D also, D here is BW. So we put dw, right? D is bw. So put bw, bw, b omega, right? Put b omega for d in 2a. Okay, in 2a. 2a is dw equals omega naught squared a plus f naught. So we have b omega into omega. This is d omega, right? It's now equal to um minus omega naught squared a plus f naught. So minus omega naught squared a plus f naught right there. Okay. So we can tidy things up here too. So um so this will be b omega squared equals minus omega naught squared a plus f naught plus f naught. We have this. So we can solve, let's call this 3 now and call this 4. So we can solve equation 3 and 4 simultaneously to get a and b. So, well, we can tidy this up first. This is a, let me use a separate color. This is a omega squared plus b omega naught squared. Or, I mean, since we are looking for a and b, right, let me make it a bit more systematic. This is omega squared a equals, omega squared a minus b omega naught squared equals 0. So this is the actual equation 3. And here we have omega naught squared a and plus b omega naught squared a plus omega squared b equals f naught. This is our equation 4 now. So this is actually the equation 4 we are solving. So we can solve the two simultaneously. So let's put them together. So we have omega squared a minus omega squared a minus omega naught squared b equals 0, right? Yeah, that's what that is about. Omega squared a minus... okay. Thankfully, thank God I quickly saw that. So this is... Yeah, this is minus omega naught squared b. So the sign doesn't still change here now. So this is still minus this. So when it comes here, it becomes plus. Thank God I didn't miss that. So that's plus, right? So here it's plus. Okay. So it's plus here. And here we have omega naught squared A plus omega squared B equals 0, equals F naught now, equals F naught. So from the look of things, we need to balance up. How do we do this? The signs are different. So if we want to eliminate, we need to multiply through by one of the two to balance things up. So now this is equation, can we call this equation 3? And this is equation 4. So to make that work, we can say equation 3 multiplied by, say, omega naught squared. So that's where we have omega naught squared plus omega naught raised to power 4 b, okay, equals 0. Then equation 4 multiplied by equation 4 multiplied by omega squared. So again, if you multiply this by omega squared, we have omega naught squared a. Okay, there's a here too, plus omega squared, omega raised to power 4b equals omega squared f naught. Okay, so we can subtract now. So we can subtract this. So we just say this minus this. Let me go black here. So this minus, oh, okay, I thought I had changed that. So this minus this. So of course, this will just cancel out. And we have omega 4b minus omega naught raised to power 4b. That is equal to omega squared f naught. Okay. So here we can get b. So this is like b into omega raised to power 4 minus omega naught raised to power 4 again equals omega squared f naught. So b alone is equal to omega squared f naught all over, if you like, omega raised to power 4, omega raised to power 4 minus omega raised to power 4. So this is what b will be like. And then with this, we can get a using any of the two. So we can use the first one, which is easier. So from that first expression, which is omega squared plus omega naught squared b, omega squared a plus omega naught squared b equals 0. So now we have b. So this is omega squared a plus omega naught squared into b, which is omega squared f naught all over omega 4 minus omega naught 4. Okay, that's b now equals 0. So we can tidy things up there. So this will be, so this is simply omega squared a equals, if we expand all that, that's going to be equal to minus, that'll be minus omega naught squared, omega squared f naught, if you multiply that out, all over omega 4 minus omega naught 4. So this minus can go down and change this over. So that the whole thing becomes positive. There's omega squared a is equal to omega naught squared, omega squared f naught all over omega naught 4 minus omega 4. So we can divide through by omega squared. So this just cancels out. So A is equal to omega naught squared f naught all over omega naught 4 minus omega 4. So this is A now. Wow, some serious issue going on here. So we can get our particular solution now that we have A and B. So what's the particular solution again? The assumed solution again is, so this is the assumed solution: A cos omega t plus B sine omega t, then C cos omega t plus D sine omega t. Okay, so we can say therefore, so the particular solution is the particular solution is xp of t, which is in two folds now. Or I think it's better to write okay, well, I can still do it this way. xp of t, which is A cos omega t plus D sine omega t. Then here C cos omega t plus D sine omega t. So we can then substitute those values. But let me look back at that again to be sure I've done the right thing. Yeah, I think that's what we have. Yes, for particular solution. Yeah, that's what we have. So we can substitute the values we've got now. So, so we can say that XP. Okay, we still have C of D to solve. That's okay. Now that's something serious. Okay, now, but it's okay. I think it's easier to get C and D now. It's easier to get C and D. So I can dial back because we need to get C and D. Oh, okay. This is serious. Thankfully, we already have relationships between all those things that to make us guess C and D easily. So we have A, B, we need C, D. So we know the relationship between, we can just use the easy ones here. So from equation 1A and equation 1B, C equals minus A omega or minus omega A, and D is omega B. Okay. So from 1A, 1B, okay, we know that C equals minus omega A and D equals omega B. Is that the idea? Let's be sure of that. Okay. C is minus omega A, D is omega B. Yes, I think that works. So we can have C to be minus omega A, right? Minus omega times A. So if A is this, minus omega A would just be minus omega, then omega naught squared F naught all over omega 4, omega naught 4 minus omega 4 there. Then D itself is omega B. So multiply omega by B by omega. So B is omega cube now, omega cube F naught. So B is, so omega multiplied by that, that's simply omega cube F naught divided by omega 4 minus omega naught 4. Omega 4 minus omega naught 4. So we have all of that. So, okay, I guess I will just jump. So the particular solution would be, so let me separate them here. So we have, let's just do XP and YP. So XP of T would just be, A cos omega T plus B sine omega T. Okay. So that means that XP of T is equal to A. What is A again? Omega naught squared F naught. So omega naught squared F naught all over omega naught 4, omega naught 4 minus omega 4 cos omega T plus B now. B is omega squared F naught and the reverse of this. So omega squared F naught, then omega 4 minus omega naught 4. Okay, that's XP of T. Then we have YP of T. YP of T is the second side of things. That's C cos omega T plus D sine omega T. So again, we have YP of T to be equal to C now. We have C to be C is omega naught squared omega F naught. So minus omega naught squared omega F naught all over omega naught 4 minus omega 4. So omega naught 4 minus omega 4. Then that's into cos omega T plus the other one, D. So omega cube F naught and the reverse. So omega cube F naught and omega 4 minus omega naught 4 sine omega T. Okay, so that's YP of T. Yeah, that's basically what we have now as our, so but then there's the resonance condition. So there's resonance condition, and that is a bit of challenge. Let's see how that looks like. So step 3, we need to consider resonance condition. Resonance condition. So we need to know that resonance occurs, right? Resonance occurs when omega is equal to omega naught. That means the external frequency is equal to the internal frequency. And in this case now, if you look at all this in all the cases, you see that once the two are the same, if you look at the denominator, omega naught 4 minus omega naught, they are the same. So resonance occurs when omega is equal to omega naught, and leading to undefined A, B, and C. A, B, C, and D. And the reason is once the two are the same, right? Since we have omega naught 4 and we have omega naught 4 and omega 4 in every situation. Like imagine it here, okay? And then look at it here too. Look everywhere for A, B, C, D, it's the same. So all of those things will be undefined at that point, but that's not the end. So in that case now, we have to now say, so in this case, in this case, the solution must be modified. Solution must be modified using the method of resonance response. Okay, using the method of resonance response. So if you use the method of resonance response, we can get a solution that will not be undefined. But although there's great a great oscillation for sure still, because of course you can already see that this is going towards infinity. So using the method of resonance response, we can improve this for sure. So, and then this term will grow. This term grows unbounded over time when we use the resonance response. So meaning that even small periodic force leads to large oscillations. So just small force can lead to very large oscillations. And that's the essence of this whole thing. Okay. So in conclusion, right, first, oscillations produce a steady state response at the forcing frequency. Two, resonance occurs when the forcing frequency matches the natural frequency. Okay, I guess I want to write this down. Let me write this. So in conclusion, right? In conclusion, okay, forced oscillations produce a steady state response at the forcing frequency. Please check the calculations to be sure I've not made any mistake, because it was really kind of tedious. Then the next thing is that resonance, as we saw, resonance occurs when the forcing frequency matches the natural frequency. So the forcing frequency in that system was the omega naught. Okay, and the natural frequency was omega naught. The forcing frequency was the omega that is in the forcing term. So leading to unbounded growth, as you can see, we got infinity, leading to unbounded growth in the amplitude. Okay, then finally, for practical applications, this phenomenon phenomenon is crucial in engineering applications like bridge design, mechanical systems, and electrical circuits. Okay, this has been a serious one. Let's just drop one practice question, and that'll be all for now. Okay, so just one practice question. So consider the system x prime y prime equals 0, 1 minus 9 minus 2 xy plus 0, 5 cos 3t. So A, find the homogeneous solution. That's A. B, find a particular solution. Find a particular solution, assuming a solution of the form xp equals a cos 3t plus b sine omega t. Then C, finally, what happens if the forcing frequency changes to omega equals 3 and the natural frequency of the system is also omega naught equals 3. So it means from what we would have solved from the particular solution, by the time you put these two together, if they cancel themselves out, it means you're going to have very large, forcing, very large frequency on the system because of that resonance. All right, so that's the end of this particular long video. And of course, you can let me know your answer to this problem in the comment section. Let me also see how helpful these videos are to you. Like, just mention it and feel free to let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. And if you have not subscribed to this channel, you'll be missing a lot because in the next video, we'll be talking about variation of parameters, of course. And of course, if you have subscribed already, and everyone, don't forget to hit the notification bell so you can always get alerted each time a new video is released. And don't forget to like and share so that more and more people can have access to the great content we have here. Till I come your way again, keep doing maths right. Bye.